Welcome, this is Saravanan, Assistant Professor, Department of AI&DS, working in KIT, Karnataka Institute of Technology. Today I am going to take the subject Design and Analysis of Algorithm. Topic is Finding Maximum and Minimum using Divide and Conquer method. So, problem statement of maximum and minimum. The maximum minimum problem in algorithm analysis, finding the maximum and minimum value in array. We are going to find the maximum and minimum value in an array. Solutions. To find the maximum minimum numbers in a given array of size n, the following algorithm can be used. First, we are using the existing navy algorithm method, and we find the analysis for the navy algorithm method. Then we find the divide and conquer method. This is the navy method. The navy method is a basic method to solve any problem. In this method, the maximum minimum number can be found separately. To find the maximum minimum number, the following straightforward method can be used. So here the algorithm problem description is nothing but to find the maximum minimum number. Max is equal to max 1, assuming the first element as a minimum number and a maximum number. For I equal to n2, if number is greater than max means we are going to assign the number equal to max. If a number is less than minimum means we are going to assign the number equal to minimum and return the value of maximum and minimum value here. Analysis. The number of comparison in navy method is 2n minus 2. The number of comparison can be reduced using the divide and conquer approach following the techniques. We are going to apply the divide and conquer method here. Okay, the navy method is 2n minus 1 comparisons. It takes a time, complexity of 2n minus 2. We are going to apply the divide and conquer method. So this is example for the divide and conquer method. First, given the elements is 33, 11, 44 and 55, 66, 62. So we get the element in maximum and minimum number. Let we derive this algorithm. Consider an array. The array contains the 33, 11, 44, 55, 66, 22. Now from the index 2 to n, okay, we can start from index 2 to n. We will compare the array elements with the minimum and maximum elements. We are going to divide the elements here. So the 6 elements can be divided into two sublists 33, 11, 44 and 55, 66, 22. Again these three sublists can be divided into two sublists 33, 11 and 44. These 55, 66, 22 are divided into two sublists 55, 66, 22. Again this 33 can be find as the minimum and maximum number. Then again this 11 and 44, this 55 is minimum and maximum number. We compare with this two sublists, we can take the minimum number as 11 and maximum number is 44. We compare as these two numbers, the minimum number is 22, then maximum number is 66. We compare, we are going to combine the solution. Finally we are going to divide and conquer means first we are going to divide the elements, then finally we are going to combine the solutions. So we are going to divide the list handling two lists separately, then finally we are going to combine the solutions. Finally we are going to combine means the minimum number is 11, maximum number is 66. So algorithm. So algorithm mainly finding the maximum minimum numbers recursively. Input or the integers are used to index the array. This maximum and minimum contain the maximum minimum value elements. If I equal to j means it contains a single element, so max is equal to a of I and minimum is equal to a of j. Else if I equal to j minus means there is contains two elements here. So we can compare with the two elements here. So if a of I is less than a of j, then max is equal to a of j and the minimum is equal to a of I. Suppose the condition is false means we move to the else part, the max is equal to a of I and the minimum is equal to a of j. Finally we divide the elements. Okay, we are going to find out the middle of the elements. So divide the list handling two lists separately. We are going to divide the elements low plus high divided by 2. Then this is the function of maximum minimum value, I, mid value, max and minimum value. We can get the value, index value, first elements, two part, middle value, then maximum value, minimum value. Divide the list handling two lists separately. Okay. So this is the first list, this is the second list. First list we can get the I, mid, maximum, minimum. Second list we can get the mid plus 1, j, max, new and min, minimum. If max, we are going to compare these two lists. If max is less than equal to max new means then max is equal to max new. If max is minimum is greater than minimum means then we can get the minimum equal to minimum mu. Analysis. So let T of n is nothing but be the number of comparisons made by the max minimum value, where the number of elements equal to n equal to y minus x plus 1. So there are the two recursive mates in this algorithm. So for each half divided sublist, hence we time required for computing the minimum and the maximum number will be T of n is equal to T of n by 2 plus T of n by 2 plus 2, where n is greater than 2. When n equal to 2 means n, where n equal to 1 means we can get the value 0. We are going to substitute the value n is equal to 2 power k, then we can get the value of 3n by 2 minus 2. So neglecting the order of magnitude, we can declare the time complexity of big O of n. So compare the native methods in divide and conquer approach, the number of comparison is very less. However, using the assembly notations, both of the approaches are represented by the big O of n. Thank you.